Hey, is it recording? Okay, it's recording now. Okay, hey, we start the lecture first. Okay. Then at the end of the lecture today, if we have time, then we can start chatting. Yeah, continue chatting. Okay. So like I mentioned, right, for the second part, we will focus on the algorithm. So today, this week, we will focus on the hash table and the graph representation. So today we will mostly learn about the hash table. Okay. Yeah, again, I mentioned this is my email. My name is Anton, and this is my email and my office number. So you can take note. Then later you can send me an email to us or come to my office. Okay. This is the course schedule of second half. Okay, you can see that we have the lecture from the week 8 to week 12 and one revision in the week 13. Okay, we have 3 tutorials happen in week 10 to week 12. Okay, and for the lab, we have 4 labs for you to practice. The lab will be in week 9 to week 12 also. Then we have 4 assignments. Yeah, the first assignment will start from week 10, and the last assignment will start from week 13. And for each assignment, you have 2 weeks to complete it. So I mentioned, right, I will try to make assignment more understandable and more manageable. Okay. And remember, we have the final lab test and the quiz. It will happen in the 21st of April, yeah, on the Thursday. So try to remark your calendar. Okay. Okay. Firstly, we talk about the this week we talk about the hash table. So you will learn about what the hash table. Then we also learn about the graph terminology, the graph representation. This will be in on Friday. Okay. We will learn about the graph. So today we will learn about the hash table. So firstly, what is the hashing? So hashing is a typical space and time trade-off in the algorithm. So normally, right, when you search, right, if you use the normal search algorithm, the best case, for example, for the quick sort or something, or for the search, like you learn about a binary tree, right? Sometimes the search time will be not linear time, not the constant time, right? It takes some time, maybe O log n or something, right? So for the hashing is the techniques that to achieve the search time in the constant time, the O1. However, like I mentioned, right, you cannot achieve the optimal search time with the optimal memory usage. So you need to trade off. So that's why for the hashing, this is the trade-off between the space and the time. You achieve the very optimal search time, yeah, O1. So they are like the constant time. But the trade-off, you need to sacrifice the memory. You need to spend some memory, or the memory usage will increase accordingly. Okay. So how we can do the hashing? How we can have the O1 or the like the constant search. So assuming, right, you have the list of the key, we call it K. Okay, it's from the universal possible key U, and we have the requirement that no key element have the same key. Okay, so for example, your key is some set of the natural number. Okay, then how can we make the search time is the O1 or the constant time? So one way is very simple. For example, right, you just create the array, and then array will start from the 0, okay, to infinite, right? And then if the key number is 3, then you just put you put the item at the 3 position, right? You put it in your key 3 and the data correspondingly. For example, you have the key 5, then you just mark it, you put it in the 5th element here. If you have the key 6, then you just put it in the 6th element here. Then this is the array to keep your keys and the data, okay? But of course, this one you can have the O1 search time, right? Because actually very easy, right? If you have the key K, right? The search time you just look at in the AK, right? Then you can directly point to the element you want. So yeah, this is the O1 or the constant or the immediately search, right? You just you have the key K, then you just call AK, then you can directly go to the element you want. But the problem here is the space, right? For example, you don't know the value of the key, right? Then you need to store all the possible natural number, right? Then you can imagine, right? You have a billion or infinite number, right? Infinite natural number. So you cannot keep like infinite the array with infinite elements in the memory, right? So therefore, we need the better way to store this. So this is they call it the hashing or hash table. So the hash table to reduce the key space into a reasonable size, but we still able to achieve the we call the constant search time. Okay. So there's some definition. They call it a hashing, right? Okay. And each key, like the value, right? You have the key. Each key will map into the unique index, or they call the hash value, or you can call an address. For example, you have one key, you map it into the unique index. Okay. And the search time still remains the O1 on the average. Okay. So that is they call it hashing. This means that, for example, you have the this is the kind of definition of the hash function. Hash function means that this is the key. They are all the possible key, right? You map it into the hash table with the H element. Now the hash table you only have the H element. Okay. Start from 0 to H minus 1. So they you only need to keep the array of the H element only instead of like you keep infinite infinite elements, right? Now the hash table only have the H elements. Okay. So this one, this array they call the hash table. Okay. So you have so for each key, right? Sorry, I'm still recovering. So sometimes I cough. Okay, so for each key, right, you try to map it into one of the value from the 0 to H minus 1, or the key, the K, right? The key value K will be mapped to one number in the 0 to H minus 1 here. Okay. So each entry here, for example, we call the hash plot. Okay. So, and if we have the multiple key mapped to the same hash value, then the collision will occur. Okay. It means that sometimes we have the key K, right? K1, we map to this one, but we may have the other value because we only have the finite number of the entries, right? So of course, if you have so many elements, then when you map, right, there's some chance that they will be mapped in the same hash value. Then a collision will occur. Then when the then we use the log factors to calculate the collision rate. So normally, for example, if you have the n record, right, nk value, then you start into the hash table with the size h. Then in average, right, each slot will contain n divided by h, right, key, right. On average, because you have the n element, then you put it into the h slot. Then for each slot, each slot, we have the average is n divided by h elements, right? So they call it the log factor, or we use the alpha. Alpha is equal to the n divided by h. Okay, so there is some definition. Again, okay. So some definition we need. We have the hash function. Hash function is just the array. Okay. The hash table they just array with the size h. Okay. So h is the size of the hash table. Okay. Then we have the key. We call the hash function to map the our key into one of the slot here, one of value from 0 to h minus 1. Okay. And because there's so many key, then maybe there's some collision, okay, occur. It means that two key may be mapped in the same entry. Then we need some algorithm to like solve the collision problem. Okay. So any question here? Any question here? I cannot see the chat, so I need to go back. Okay. Okay. There are no question yet, so we continue, right? Okay. Then we talk about the hash function. The coding example for this one. Yes. In the lab, I will give some example for you. Okay. For the hash function. The recording. Okay. Wait. I will. For the recording, right? I will upload it in the NTU Learn. I will make announcement. Okay. In NTU Learn. Okay. Another question. For the lecture notes, normally the lecture notes we don't have the code exam. Actually, for the hash function for the algorithm, right? We sometimes we have some code example. Sometimes we don't have, but in the lab I will provide the code for you. Okay. For example, how to create the hash function. Actually, for the hash function, it's easy, right? It's just array. It's just an array, right? The hash table is just an array. And then, yeah, that's it. Yeah, it's just an array. It's just about how you define the hash function and something like that. Okay. Just back to another question. Is about the h on way greater or equal than n. H is the h is cannot normally, right? The h is smaller than the n because h is the table size, right? The h is the table size, and we don't want to n records in the keys yet. So normally, right? For example, you have how to solve the collision. We will learn about that later. Yeah, I mean, right now, up to now, we just learn some terminology about the hashing. So how to solve the collision, we will learn right after. Okay. So I just try to answer some question now. Okay. Yeah, hash function is just like not a stack. It's just hash function is just an array. Frankly speaking, hash table is exactly the array. Hash table is array. I mentioned here. Hash table is array. Yeah. Okay. Yeah, and the hash function is just a function. And which function we will learn later. Okay. So now I mentioned about it's just an array. Yeah. Frankly speaking, yeah, in the Python they also have the hash table. There's some utility, but frankly speaking, for the hash, it's just an array. Okay. So for the relationship between the h and n, right? So because, for example, you have the 1,000 elements or 1,000 keys, right? You want to have map it, then you can create the 1,000, the array of the 1,000 elements, right? But sometimes we want to save the space. Maybe we just create the array of the 100 elements, okay? Because we want to save the space, right? Then normally, right, the k will greater than the h. Okay. Normally. Okay. But sometimes if you know that, okay, the number of the k is not so big, then okay, you mean the h and k, right? H is the hash table size, the size of the hash table, and the k is the keys. It means that you can have like okay, simply, right, for example, the key can be your matriculation number, matrix number. Okay. For example, you have 800 students. I want to store the 800 students. Okay. Then the key will be your matriculation number. Okay. And then H is something that we want to keep it in the database, right? We have to store your matriculation number. Okay. Then how to store it? Okay, to keep it like the constant search time. Okay, I can create the array 800, okay, in the memory, right? Then one of you, I just, okay, the first one, I just put 1 to 1, right? But sometimes if we have million of the student, like the student of the whole country or something. Yeah, actually the dictionary in the Python, they use a hash to keep it. So the hash function is something inside some data structure you use. For example, in the dictionary, they may use the hash table to keep it. Okay. So when we do the hashing, we expect to okay. So maybe some of the question I will answer later. So yeah, the dictionary is not ordered. Yes. Dictionary is just used to have the constant time. Okay. Yeah, correct. The hash table is just to store all the key to make it into the unique thing so that you can search in the constant time. Okay. So normally the key like very large, the number of the key very large. You have 1 million students. You cannot store it in the 1 million element in the memory. You just keep it to store it in the 100,000. Then you need to have some mapping techniques. Okay. Understand? Yeah, that's the hash, the meaning of the hash table. Hash table you to store the data, the huge data into some memory so that you still have the constant search time. Then one one key will map into one directly map into the one hash value. Okay, so that you can later you just use the hash value to retrieve the elements immediately, right? You just use the constant time. But because maybe they many keys have the same hash tables, so there's a collision. Then we need to solve the collision. Okay. Oh, how can we use the 100,000 hash key, right, to map 1 million data? Then now we need to solve it. There's some collision, right? Then how to do that? We solve now. Okay. So we continue. Okay. That's it. They call it hash function. How you map a key into the hash value. Okay. Of course, like you need to map all the possible value into the range of the hash table, right? Like you mentioned, how 1 million map into only 100,000, right? So the hash function create the mapping, okay? And the hash table, yes, store the mapping, okay? Okay, sorry. I think when okay, sorry. I think the sharing is off, right? Should I share again? Yeah. Sometimes when I escape, then the sharing off. Okay, sorry. Okay, then we learn about the hash function. Okay. So like you mentioned, right? The hash function is you map the key into the hash value. Okay. So like how you map each student into each entry in the hash table. Okay. And there's some criteria that the mapping should achieve the even distribution of the keys. It means that when you map right, then in the hash table, right, each entry, right, I mean the distribution should be equal. It means that one entry cannot have like 100 of the key, but the other entry only have one. So the distribution of the keys in the hash table should be equal or even distribution. Okay. And of course, it needs to be easy and fast to compute. Yeah, you cannot create a very complicated function and you ask the computer to calculate it in the half day just to calculate the hash value. And of course, it needs to minimize the collision. Okay. Minimize collision, it means that, of course, if you have so many keys, then you have the limiting of the hash value, then of course there's collision, but you need to minimize the collision. It means that you should achieve the even distribution, right? Even the collision, but the collision should be distributed evenly for all the hash values. Okay. So there are a few hash functions. The first, they are modular arithmetic. The second is folding. The third technique is mixed square. The fourth one is a multiplicative, congruent methods. And a few more, but I mean in this lecture, I will introduce 4 common techniques. Okay, the first one, we call it the modular arithmetics. Okay, so it's just very simple. You have the value k, right? And you have the hash value h, right? I mean the size of the hash table h, right? How to map it? For each key, right, you just use the k and you do the modulo with h. Okay, for example, you have h is the 17. It means that in your table you only have 17, right? 17 space. Okay, for example, 0 to 16, right? Okay, then if you have the key 37699, then how you map it? You just do the modulo. 37699 modulo with, I think this should be 17. I make that wrong one. Yeah, just do the modulo with 17 and you got the 12. Then you put the 12, for example, this is the 12. Okay, then you put the 37699 here. Yeah, that's it. So you just do the modulo. Okay, it's just like how to map your matriculation number into the hash table. You can just put keep the numerical number, right? You do the modulo with some hash the size of the hash table h. Yeah, for example, here is 17. Then just do the modulo with 17. Then you can map this one. Okay, so they are very simple hash function. Okay, actually, like I mentioned, right, in practice, right, you should have the even distribution, right? So normally in practice, people choose the H should be the prime number. Okay, it's just a round number, and just one small notice that it should not choose close to the any power of the 2. Okay. Oh no, I think this one is 13. Yeah. Oh, sorry. Yeah, 17. Okay. Anyway, yeah. So in practice, people usually choose the H is the prime number. Okay. It not too close to the any power of 2. Why is it? Because in the mathematics, people already proved that if the H is the prime number and not too close to the any power of 2, then normally you have the even distribution. Okay, even though your data is not quite even distribution, but when you use H value is the prime number, then when you map it into the hash table, the distribution will be quite even. Yeah. Okay. The second way you do the for the hash functions is the folding. Folding is you partition the key into the several parts, and you combine the parts in the convenient way. So normally people use a shift folding. This means that they divide the key into the few parts and then they just add up together. Okay. For example, if you have the X, the key is ABC, right? Then when you hash this key, then you just add the A plus B plus C, and then sometimes you do the modulo, to make it smaller. For example, you have the very large number here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then when you do the hash function, right, you just, for example, you divide into the 3 part, okay? Then you just add 3 parts together, and then you can just modulo with some number, then you might make into the hash value 3. Okay, so you can use it to map a very big number into the hash value. Then you store it, for example, 3 here. Then you store this one there, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. I'm not so sure anyone asked the question. Okay. So the other hash function we can do is we can also do is a mixed square. Mixed square also quite simple. This means that the key, you square the key, and you use the middle part as the hash address. Okay. For example, you have the key value 3121, then you just square it. For example, 3121 squared is the big number, and then you choose a middle part. For example, you choose a middle 3 is the key number. Okay, it means that you square it, and then you choose the middle number as a key value. Okay. So why? And the last one is you can do the multiplicative congruent tool. This means that you just multiply with the key with a very random number, for example, A. Then you just multiply, and then you do the modulo with H. Okay. For example, you have the key is 5, right? Then you have random number. You just choose a random number, for example, 13, and you do the. Oh, I think H is 6. I think wrong. Yeah, random number is 6. So you just multiply K with a 6, okay? And modulo with 13. 13 is the hash size, right? A hash number. Okay. The hash size. So the final hash value will be 4. This means that if K is 5, then you map it into the 4 element. So it's the hash function. Okay. So the hash function, there are many other hash functions available. So what the hash function used to be, it used to map a key value into the hash value. Okay. And why we need to have so many hash functions like that? Actually, these hash functions they just help why? Okay. So these hash function they just used to map why I see your comment. I need to close a cell window. Okay. Anyway. So for the hash function, actually they just want to map a key value into the hash value, right? And why you need to have so many hash functions? It's just because you remember, right? What are the criteria for the hash function? You need to have the even distribution of the key. Okay. So the hash function, for example, mixed square or something, or the multiplicative congruent methods, or the folding or something, they just try to make it like even distribution. Okay. For example, you have some key value, then they try to make it even distribution into the hash table. That's it. So the different hash function they just try to make it have the even distribution when you map it into the hash table, so that when you map on the keys value, right, then the distribution of the hash value should be even distribution. It means that they should make it equally in the slots. It means that it cannot be happen like some slots have so many number, but in some other slots they no number or just one or two number. Okay. So let me answer some of the question here. 37699. Sorry, I mean in the example, the 37699 should be modular with the 13. Yeah, not a 17. Yeah, there's some bug in the yeah, the hash H is 13, not 17. Okay. For the folding methods, right? When we use the 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Whether we can split it into just like 1 at 2 at 3 at 4, yeah, it's up to you. You can split it into each like each individual number, or you can use the like change of the tree. Yeah, it's up to us. Okay. We will cover the MD5 or SHA1 in this course. We won't. These are more advanced technique. I mean, this is more advanced technique. If you want to explore, I will put it in the lecture note. Okay. But you can learn it by yourself, because this one is just teach about the basic knowledge. Okay. For the folding methods, right? Using the code. Folding methods is just simple, right? If they ask you, okay, folding tree, then you have the, I mean, you have the non-numeric, then you need kind of methods apply to the non-numeric, right? For the non-numeric, you need to just define how you convert the non-numeric number into the numeric items. For example, you have the S858. For example, your IC number or your student card, right? Start with S, right? S858. Then you can define S can be the order in the alphabet number. S can be converted into 22 or something. Yeah, it's up to you. Then you convert the non-numeric number into the numeric number, and then you apply the hash function. Okay. For the pseudocode, okay. For the SHA1 and the MD5, right? what the relation between them and the methods I mentioned, right? The method I mentioned is very simple method. It just, tell you about how the idea. But for the SHA1 and the MD5, it's a bit more complicated. Okay. But it all used to map the key into the value. But you can use more advanced. Okay. Yeah, of course, SHA1, now SHA256, they convert the non-numeric, right, into the number, but it's MD5 also something. But here in the lecture, I just give you some idea. The hash function is just, there are so many hash functions. If you ask me, there are thousands of the hash functions. Okay, there are so many techniques. It's just because whether they have some security things or something. But the hash function is just used to map the key into the hash value. And you have so many functions to do that. Okay, so the four function I teach you is just a very simple function. Okay, so for you to understand it. Okay, we can use the hash function to access the data in the array. Yes, you use a hash function to access the data. We can also use a hash function to access the data in the array. What you mean the array? Array now is already the hash table, right? The array is the hash table with the index from 0 to h-1, right? And the hash function map the key into one of the value from 0 to h-1. Okay. And after you map the key value into the one of the value between the 0 to h-1, you just use the array with the index, then you can directly access the data in the array or access the data in the hash table, right? So that's the search time is O1, right? Because, for example, the hash table is A, then you have the hash value. For example, after you have the hash value 3, then you just access A3, right? So that's why the search time is O1, okay? So understand now, right? For the hash table, it just gives to map the key into the value, okay? So there are so many ways to map it. So in this lecture, I just give you 4 very simple ways, okay? But in the practice, of course, you have so many ways, SHA255, then blah, blah, something. Is there any reason we wouldn't want to use hash function? You have to use the hash function. Because how can you convert the key into the hash value? Hash value is just a one value from 0 to h-1, right? Your key can be the very huge number, or it can contain the, some non-numeric numeric values, right? For example, your SIC and your NIC. Then how you choose, how you convert the NIC into the value, right? So you need some hash function. Yeah. Yeah, you in practice we just choose one and use it. It's up to your design, like you are designer. How I design the hash table, it's up to you. Yes. You mentioned how to retrieve, then we learn about it right now. Okay. Okay. Any reason we wouldn't want to use hashing or hash table at all? If you, of course, you can. It's not forced that you need to use a hash function. But yeah, for example, just a small number, just a few students, a small number, then you don't need to use the hash table, right? For example, if you know that, okay, on the index, I only have, for example, you want to store the index number, and you know that only 100 index, then why did you use a hash table, right? And you know that, okay, on the index only from 1 to 100, then you don't need to use the hash table, hash function anyway, okay? Because you know that only 100 from value from 1 to 100, then you just use the array with the 100 elements, okay? So what is the application of the hash table? It means that when you want to store when you store a list of the very huge number of the elements, and you want to make the search time is O1. Okay, very huge. For example, 1 million of the elements, or 1 million of the NIC number. For example, when you want to store the NIC number of the Singaporean, yeah, million of the number, right? Then you use the hash table. Okay. How to retrieve the original data? Then we will learn right now. Okay. Okay. So I continue sharing, because when I share the things, right, I cannot see your chat. So I need to stop in the middle to answer some questions. So we continue. Okay. So sorry, sometimes when I sharing, I teach, I cannot see your chat. So I need to stop it in the middle. Okay, we continue. Okay, so you know how to like map it, right? Map the key into the hash value. Okay. Now we continue. Okay. Now we know about that. After you map, there's some collision, right? So how to do the collision resolution? Okay. So there are two main approach. The first one they call a close address hashing, or we know as the separate chaining. Okay. The second one is open address hashing. So we have a few way to do the resolution. For example, linear bropping, quadratic bropping, or double bropping. Okay, so we learn one by one first. For close address, close addressing, or the separate chaining, right? So the key are not stored in the table itself. So remember, right? After we map a key into the hash table, right? Then we need to store it, right? So this one, actually the key is not stored in the table itself. And the set on the key with the same address, we will store in the separate list, for example. Okay. So this, for example, this is the hash table T. Okay. Then this is the element, the value I. Okay. Then, for example, you have four number 84, 39, 92. Okay. Then somehow when you apply the hash function h, they're all the same, map into the element I. Now you have three number, map it into the same hash value I. Okay. And this is the element I. Okay. How you store it? Very simple. This is the table, right? The hash table or the array T, right? So you just use a linked list. Okay. For example, firstly you have the 84. You map it into the element I in the array hash table. Okay, T. Then you make a linked list point to this one. Okay. Then later you have the 39. Then you just make a linked list point to the 39. Okay. Then later you have the 92 also mapped into the same value. Then you just make a linked list. Then if you have more value, you just link together. Okay. So it means that to implement it, the array will just the hash table is just array, right? Hash table you just array, right? Array T with the size is h, right? This is the hash table. And then when you do the hash function, you apply any hash function, okay? And somehow if the hash function gives you the value I, then you just make the linked list, right? Okay, you just append the new item one by one, okay, when you insert. Okay. For example, firstly, you have 84. Then you don't store the 84 here. You don't store here. You just make the not to point to the not 84. Okay. And then later you have the 39. You point to the 39. Then later you have the 92. You point to 92. It means that here one item may have a few elements. Okay. Then one of them point to the others. Okay. Yeah, something like that. So that's the way we solve the problem of the collision. Okay. It means that we have the key. If you map it into the hash value I, right? Then you see that in the hash value I already have the sub elements, right? Then you just append it at the last one. Okay. So for example, you have for example, you have 100 here, right? Then you just append 100 here. Okay. Right. So it means that how you implement it. So each element here will be a linked list, right? So this is the array of the linked list. Okay. Correct. So you have if you implement it in the code, right? So it should be array of a list, right? A linked list. Yeah, this should be the linked list. Okay. We can write linked list. Okay. Right. And each item will be a linked list, like this one. Each item is a linked list. So they are the way we implement it in the code. Array of a linked list. Okay. So you define array of the linked list, and each item will be one linked list. Okay. So at the beginning, it's just the null value, right? Okay. The null value. Okay. Then when you insert, then you just point it, make the null value. You point to the items. Okay. So that is called the close address. Okay. How we search or how we retrieve, right? So how we retrieve this? So very simple. Now after you have this one, right? How you retrieve the value of the 90, for example, 39, right? Then again, you make the 39, you make the hash function 39. Okay. Then you know the value is k. Then 39 go to the k. Then you go to the hash item k I. Okay. Sorry, I. Then you search 84. It's not the one. Then you go to the 39. Oh, 39 here, the key, the same key. Then you retrieve the value, yeah, the data. Maybe for example, you store the data here or something. Yeah, then you get the data. Okay. So they are the way how we retrieve the value from a key if we use the hash table. It means that we use a hash function to get the hash value. Then we access the hash value, right? Then we just search it into the linked list. If they're the exactly the same hash, I mean exactly the same key value, then we retrieve the data corresponding to the key value. Okay. Then the collision here is if we have a collision, we just make a linked list, link on the item with the same hash value into a linked list. Okay. Then when we do the searching, we just search sequentially. Okay. For example, 39. If we have the 39, right? When we do the hash function, we know that it's in the item I. Then how we search? We start with the first time. Then we move to the next one. 84. It's not. 39. Oh, yeah, it's correct. Then we retrieve this one. We retrieve this one. Okay. So in the closed address, right, there will be you remember for the alpha, right? Alpha I mentioned, this is the number of the collision, right? So normally if the even distribution, right, then for each linked list we have the alpha number in average. For example, you have the 1,000 of the student, you map it into the table, the hash table of 100 elements. Then of course, in each element of the hash table, there will be a linked list, right? And the length of the linked list will be 10, right? If you have the even distribution, right? So 100 students, you map it into the 1,000 students. You map it into the 100 item in the hash table. Then each item in the hash table will have the linked list of the 10 students. It means it store the information of 10 students. So they call it a separate chaining. Okay. So now we need to calculate what the time complexity of the worst case analysis. The worst case analysis, when the worst case analysis happen? The worst case happen. The worst case happen, you understand, you can imagine, right? The worst case happen when you map on the item, it just go into the one single hash value, right? It means that one single hash value store on the items. While the rest of the hash table empty, just one item store on the table. Somehow in the worst case, right? We do the hash function, so it on map into only the third element. Then it's a worst case, right? So in the worst case, it means that all the element hash into the same slot. So it means that the linked list will contain all the n elements, right? This is the worst case, of course. So if the worst case, right, if in the unsuccessful search, it means that we search the key, but actually the key not in the table, then we need to travel on the elements, right? And now because in the hash table you only have one active one, it's stored on the element here. So you need to do the sequential search, right? Because they are linked list, you need to do the sequential search until the last element. But because the key is not in this one, so you need to search at the end, and you find that there's nothing, no key, no match key. Then you stop. So that it takes the n comparison. So the complexity will be O(n). But for the successful search, right, you assume that the probabilities for each search will be 1 divided by n, right? Because they are just a probability, but you have n number. So the probability for searching each element will be 1 divided by n. Okay. And then and how far you need to search. So if the item in the first one, so you only need to travel 1, right? But if the item in the second one, you need to travel 2. If the item in the third one, you need to travel 3. Okay. So that's why you need to sum on the number from 1 to n. Okay. So that's why 1 divided by n sum time with the sum of the I from 1 to n. And this or is a when you calculate it, it becomes the n plus 1 divided by 2 or O(n). Okay. So if the successful search, so the complexity is just like the sequential search. Yeah. So they are the worst cases. Okay. The worst case. The worst case, the searching O(n). Okay. For both successful and unsuccessful search. Okay. How about the average cases? Average cases. So again, the average cases mean that you have the hash table and you divide equally. It means that each item have the same number. For example, each item here only have 2 number equally. Okay. So they have the same distribution. Okay. It means that you divide it quite nicely. Each item in the hash table have exactly 2 elements, okay, or the linked list only have 2, okay. So this is the average cases, okay. So it means that if you have the h slot, right, and you add the n, so each one will have n divided by h, right. So that's why if unsuccessful search, then after you do the hashing, right, you do the hash, you apply the hash function, you get the key value, then you only search for one array, one linked list here, right, and you need the n divided by h, because only n divided by h element in each linked list, n divided by h, okay. So therefore the unsuccessful search will take you n divided by h. For the successful search, right, for example, when you search this one, right, so before this one you have the n element, right, so before this one you have n minus 1. So I mean, here I just give you, sometimes if you have time you can read it, but I mean there's a bit complicated, but you don't need to much worry about that in the exam. I don't challenge you about this one. So this one, if you want to understand how I mean how we calculate the complexity or something, you can read it. Here I just explain roughly. If you feel very complicated, you can actually ignore it, but you just understand that, okay, at the final value, okay, the final number. So okay, but if some of you are more interesting on how to calculate this, you can read this one, okay. But anyway, the final complexity will be O1 plus alpha. You remember alpha, right? Alpha is n divided by h. Okay. So the complexity should be the n divided by h. Okay. O plus 1, O of 1 plus n divided by h. And if you choose the h is proportionally to n, then n divided by h will be constant number, right? For example, if you choose you have the 1,000 of the student, and you choose that, okay, how you design the hash table. So you decide that, okay, the hash table will be the 1/10 of the number of students. It means that you have 1,000 students, then your hash table will be 100, right? 1/10. The n divided by h will be 10, right? It means that the time complexity will be still the constant, right? Because n is h will be proportional with n, right? So n divided by h will equal to some constant alpha. Okay. So therefore, the complexity for the average case will be the complexity will be constant. Okay. Then how to do that? Okay, this is I show how to do that. If you have time, you can read it. If you don't have time or you feel that very complicated, then you can just remember, okay, the average complexity for the separate chaining is still constant. Okay, constant time for searching. Okay. Or if later if you read it, I mean, when you want to understand but difficult, then you can ask me. Okay. But here, because I mean, this one you just need to understand here should be the constant time. Okay. So any question for this one? So for the separate channings, I mean the idea is very simple. If you map it into the map it and they have the collision, right? You just make a linked list and you make a chain to connect on the item that have the same hash value. Okay. And when you search, right, you will do the same thing. You do the hash function to get the hash value, right? And from that, you just search in the linked list which one have the same key. You find the key, right? And then you can retrieve the element. Okay. So let me see. Anyone ask the question? I think in this week we will stop. I mean, in today we will stop here. Then we'll continue on Friday. But I will try to answer on the question here. Okay. So if you have any question, you can stay here to ask me. One question will be the search time is no longer 01. It's still 01. Like I mentioned, right, for the traveling the linked list, right, it's still the constant time. 01 means that the constant time. If you choose the H proportionally to the n, then it's still the constant time. Okay. So while the lecture is recording, and we'll share you the record link later. For the assignment, it will be out after the second lecture of this week. It means that it will be out in the later of this Friday. But you will be given the 2 weeks from the date of the release.